Today we are going to discuss some numerical problems on oscillations. The problem is given: the motion of a particle executing simple harmonic motion is given by y is equal to a sin omega t, where a is the amplitude of motion, omega being the angular frequency. Now given that if it has speed u when the displacement is y1 and a speed v when the displacement is y2, show that the amplitude of motion is given by v square y1 square minus u square y2 square divided by v square minus u square whole to the power half. That is, the velocities of two positions y1 and y2 are given, so we have to determine the value of the amplitude. The expression of the displacement of a particle executing simple harmonic motion is given by y equal to a sin omega t, we know. Then if we want to obtain the velocity, just taking derivative with respect to time, v is dy dt, that is a derivative of sin omega t gives us omega cos omega t. So the expression of velocity of a body executing simple harmonic motion is given by v equal to a omega cos omega t. So we have y equal to a sin omega t, that is the displacement, and velocity v is a omega cos omega t, the velocity. And now from the expression of displacement we have sin omega t is equal to y by a, and from the expression of velocity we can write cos omega t is v by a omega. And from the trigonometric relationship we know that sin square omega t plus cos square omega t is equal to 1. Now putting the values of sin omega t and cosine omega t, which we have obtained earlier from the expressions of displacement and velocity, we got that sin square omega t is y square by a square and cos square omega t is v square by a square omega square. So according to the relation we have y square by a square plus v square by a square omega square is equal to 1. According to the given condition of the problem, we have the value of velocity at the position y1 is u and the velocity is v when the displacement is y2. Now we have obtained the relationship between displacement and velocity as y square by a square plus v square by a square omega square is equal to 1. Now putting the boundary condition given, from the first one we have the displacement y1 and velocity u, so we have y1 square by a square plus u square by a square omega square equal to 1. We mark it by equation 1. And from the second relationship where we put the value of displacement y2 and the given velocity v, so from we have y2 square by a square plus v square by a square omega square is equal to 1. We mark this by equation number 2. From the equation 1 we can therefore write by changing side y1 square by a square minus 1 is equal to minus u square by a square omega square. So in the left hand side we get y1 square minus a square by a square is equal to minus u square by a square omega square. Therefore just rearranging, we have omega square is equal to minus u square divided by y1 square by a square, whereas a square and a square cancels out in the both side. So we have omega square is equal to minus u square by y1 square minus a square. We mark this number equation number 3. Similarly, from the second equation which we have obtained from the boundary condition, we get again y2 square by a square minus 1 is equal to minus v square by a square omega square by rearranging the terms. And therefore in the left hand side we have y2 square minus a square by a square is equal to, in the right hand side, minus v square by a square omega square. So therefore we get similarly from here omega square equal to minus v square by y2 square minus a square. We mark this by equation number 4. Now just equating the value of omega which we have obtained from the equation 3 and 4, we have in the both side u square by y1 square minus a square is equal to v square by y2 square minus a square. So just rearranging, we get y2 square minus a square by y1 square minus a square in the left hand side is equal to v square by u square in the right hand side. Now just changing side and rearranging, we get a square is equal to y1 square v square minus y2 square u square by v square minus u square. And just from this expression we get the value of amplitude as y1 square v square minus y2 square u square divided by v square minus u square. So this is the answer. Now just consider a similar problem where numerical values of velocities of a particle executing simple harmonic motion have been given in two different positions. That is, at an instant of time, displacement of a particle is 12 centimeter and velocity is 5 centimeter per second, and when the displacement is 5 centimeter, the velocity is 12 centimeter per second. Now calculate the amplitude, frequency and time period of motion. So in this problem, just numerical values of the velocities are given as u equal to 5 centimeter per second and v is 12 centimeter per second, at y1 12 centimeter and y2 is equal to 5 centimeter respectively. So we have to obtain amplitude, frequency and time period of the motion. Now to solve the problem, we know the expression of velocity of a body executing simple harmonic motion is given by v is equal to omega into root over of a square minus y square, where a and omega are the amplitude of motion and circular frequency respectively. Here according to the problem, whenever the velocity is 5 centimeter per second, the displacement is 12 centimeter. So we get from this expression 5 is equal to omega into root over of a square minus 144, that is 12 square. Similarly, when the velocity is 12 centimeter per second, the displacement is 5 centimeter. So similar equation gives us 12 is equal to omega into root over of a square minus 25. Now if we divide these two equations, we get 5 by 12 is equal to root over of a square minus 144 by root over of a square minus 25, where omega cancels out. Now just squaring and rearranging and interchanging the terms, and we get here the expression for amplitude a square is equal to 169, which yields us a is equal to 13 centimeters. So by just mathematical calculation we can easily find out the expression for amplitude from the given condition. Now we have obtained the expression for amplitude 13 centimeter, the value of amplitude, and now using any one of the condition and using this equation v equal to omega into root over of a square minus y square, if we put back suppose y1 is 12 centimeter and u is 5 centimeter per second and the value of a is 13 centimeter, then from this equation we can easily calculate the circular frequency omega, and by using our very known relationship omega is equal to twice pi n, we can calculate the frequency. And for the time period, we know the relationship between time period and angular frequency as t equal to 2 pi by omega. So if we put back the value of omega in this relationship, that is t equal to 2 pi by omega, we can also easily calculate the time period of motion.